continue solving the the MCQs, and tell me, when is your exam scheduled for
The
chemistry?
midterm is on Tuesday.
On Tuesday. Okay. So we will try our best to complete the MCQs in
Okay.
this class so that we can discuss the subjective portion in our next two classes. Okay, so we will quickly start with this question. We are given that the diagram, it shows the colors of the indicators methyl orange and methyl red at different pH values. You are given the colors for methyl orange and methyl red. The table shows the pH of four solutions. For solution W, the pH is 2. For X, it's 3. For Y, it's 5. For Z, it's 6. In which solution will both indicators be yellow?
Methyl, Y, B, A,
W has 2, so it's red. For both of them, it would be red.
okay.
For X, it's 3. And what's the color? And the
Right
pH will
here.
be 3.
Axis 3 is. The answer is C, Y and Z.
Y
And
and
Z.
Z. Y has the pH 5, so its color would be, for methyl orange, it would be yellow. And for methyl red, is it yellow?
Methyl red 6 is yellow,
If we look at Y, you can see its pH is 5.
yes.
It's written that in which solution will both indicators be yellow? In solution Y, if I have solution Y in a beaker, methyl orange, it would be yellow, right? Because its
Yes.
pH is 5. But if I uh, consider methyl red, would its color be yellow? No, it would be red. You
Oh,
can see that methyl red, it only gives you yellow when the pH is 6. From 2 to 5, it gives you red. So we have to look for the solution in which both the indicators are yellow.
okay. So D.
Yes, Z only, right?
Yes.
Yes, very good. Okay. Now we are given that which graph shows the change in pH as an excess of hydrochloric acid is added to aqueous sodium hydroxide.
Excess of hydrox
Initially, we will have the aqueous sodium hydroxide. Is it a base or a
base
acid? Yes. So what should be the starting pH value?
for 13 around 14.
Yes, it should be near 14, right?
Yes.
Because in the start we will have sodium hydroxide. After that, when we will start adding the hydrochloric acid into this base, what would happen? The pH, it will start decreasing slowly, right?
Yes.
And then,
It will go like so hydrochloric acid will be excess, so it will go down.
yes, if we keep on adding, like there will come a point when the pH will reach 7, like they will neutralize each other. But after that, if we keep on adding the excessive of hydrochloric acid, what will happen in that case? The
It
pH will
will
keep on dropping, and
drop
the
into
solution, it will become acidic. So which graph seems
D.
correct? D. Very good. Okay, then we are given that which statement does not describe a property of a weak acid in solution? Does not describe the property of a weak acid in solution. It forms a salt with sodium hydroxide. It has a pH of 8 and 9. It is only partly dissociated into ions, and it reacts with sodium carbonate to give off carbon dioxide. Which of these is false? Does not describe means that which of
B.
these is false?
B.
P, that it has a
B.
pH of between
8 and
8
9.
and 9. Very good, excellent. Is the first one correct? It forms a salt with
Yes.
sodium hydroxide. Very good. It is only partly dissociated into ions. Is this correct?
It is only, yes, it's correct.
Yes. Because we are talking about the weak acids, and we know weak acids that only partially get dissociated. It reacts with sodium carbonate to give off carbon dioxide. Is it
Correct.
correct?
Yes.
Yes. So only option B is the correct option for this statement. Okay, then we are given that which products are formed when dilute hydrochloric acid. It reacts with the substances that are shown in the table. When we, if we react the iron, okay, if we react the iron with the hydrochloric acid, will the products be iron chloride plus hydrogen only? When if I react iron carbonate with hydrochloric acid, the products will be iron chloride and carbon dioxide gas only. When we react carbon oxide with hydrochloric acid, the products will be iron chloride plus oxygen gas only. And if I react iron sulfate with hydrochloric acid, the products will be iron chloride plus sulfur dioxide only.
Is it A?
Which of these gives us the
A.
um, option A? When we react iron with
Salt
hydrochloric
and
acid, we will
hydrogen
get
gas.
iron chloride plus hydrogen gas. A? Yes, very
Yes.
good, excellent. What about option B? Why is this not correct? When we react iron carbonate with hydrochloric acid, what do we get?
Iron carbonate with.
Or second option, iron
uh,
carbonate. If we react
because
iron carbonate with hydrochloric acid, what would be the products in that case?
we get
Iron
like
carbonate is
water, we get like water and carbon dioxide. Yeah.
plus HCl. We will get iron chloride.
Mhm. And chloride and like carbon dioxide and water.
Very good. Carbon dioxide plus water. Water is also produced, but in the description we are given that only iron chloride and carbon dioxide is gas is produced, but in reality water is also produced. In option C, iron oxide. What happens when iron oxide reacts with hydrochloric acid? What do we get in that
We
case?
get water, not oxygen.
We get water
Salt and
and
water.
yes, we get iron chloride plus water, not oxygen gas.
Mm.
That's why it's not correct. So in this one, if we have iron oxide and we reacted with HCl, what about the last option, iron sulfate?
Iron sulfate.
Yes.
It's it's wrong. Its reaction is supposed to
Dilute
be
HCl, it does not typically react with
yes,
iron sulfate in a way
sulfate.
that
Yes.
produces a sulfur dioxide gas. That's why it's not correct as well. Only option A is correct. For which process does not result in the formation of both carbon dioxide and water? Addition of a dilute acid to a carbonate. What do we get? When we react an acid with a carbonate, what do we get? Like, tell me the
Acid and
general.
carbonate, we get salt, carbon dioxide, and water.
Yes, very good. It means that we will get both the carbon dioxide and water, right?
Correct.
But we have to look for that process that does not result in the formation of both of them. The first one will give us both of these carbon dioxide and water, both will be produced. What will we get by the burning of ethanol?
Burning of ethanol.
Yes.
So burning of carbon dioxide and hydrogen.
No. Carbon dioxide and not hydrogen. By the burning, combustion. Burning means combustion reaction.
Okay.
So, what are the products that we get from a combustion
Carbon
reaction?
dioxide,
Yes, and what's the other
uh,
one?
oxygen,
Water. We
water.
always get carbon dioxide and water. So,
Okay.
when you burn ethanol, you will get carbon dioxide and water. What do we get by the burning of methane?
Uh,
This is again a
we
combustion
get
reaction, and it will
we
again
get carbon dioxide and water also.
yes, combustion reactions they give you carbon dioxide and water. These three they are giving us both the products, carbon dioxide and water. If you look at the last one, heating crystals of hydrated sodium carbonate. What do we get?
Um, we get
Hydrated sodium
D
carbonate. Heating the crystals.
D. Okay. Okay.
It will, yes, it will give you the anhydrous salt, like the anhydrous form of this salt, plus water vapors will be evaporated from it. Because if we heat the hydrated salt, it will get converted into anhydrous salt, right? Now, if I
Hmm.
have sodium carbonate, it's Na2CO3 and it contains 10 water molecules. So if we heat it, the salt will become anhydrous. So it would be Na2CO3 plus water will be evaporated. So it will produce 10H2O. But in this reaction, you can see we are not getting any carbon dioxide being produced. It is only giving us water as a product. So this is the only correct option, which is not giving us both carbon dioxide and water. Clear?
Yes.
Okay. Then you are given the table. It gives information about three indicators. Okay, if we have the methyl orange from low pH, going from low pH to high pH, the color turns from red to yellow. pH at which the color change takes place, it's 4. And then we have the second indicator, which is bromo thymol blue, and its color changes from yellow to blue and it changes at 6.5. Then we have phenolphthalein. It changes color from colorless to pink when the pH is 9. If equal volume of these three indicators were mixed, which color would be observed at pH 5?
I
Yes.
uh,
What would be, you have to check for all of these. At pH 5, let's say I have mixed all of these three indicators and the solution it has the pH of 5. So what would be the color of methyl orange when the pH would be 5?
color of methyl orange and the pH orange.
No, you are given the color changes. When it always changes from red to yellow. First it would be red, then it turns to yellow. And when does the color change take place? When the pH reaches 4, it means that before, like if I have 4, if I have any pH value that is less than 4, it would be red, and if it becomes greater than 4, if the pH becomes greater than 4, then its color will turn yellow. For bromothymol blue, it's written that the color change takes place at 6.5. And how does the color change takes place? It changes color from yellow to blue. It means that if its value is less than 6.5, its color would be yellow. And if it's And if its color and if it's changes the pH, or if the pH is greater than 6.5, then its color would change to blue. Same happens over here. If it's the color change take place at 9, if the pH is below 9, it would be colorless, and if the pH goes above this 5 9, it would turn pink. Now you have to check what would be the color of all these three indicators when the pH would be 5. What would be the color of methyl orange when the pH would be 5? Would it be red or yellow?
And 5 yellow.
Yes, because initially it would be red. This arrow indicates that first it would be red, then it will turn into yellow, and then it's also given that at what point will the color change takes place. At 4. When the pH reaches 4, its color will turn from red to yellow, and it will remain yellow when it will go beyond 4. This is how we analyze it. So when the pH would be yellow, when the pH would be 5, the color of methyl orange, it would give you yellow. This is the color for the first indicator. Now, if we talk about the next indicator, which is bromothymol blue, what would be the color of this bromothymol blue when the pH would be 5? Initially,
Yellow.
it should be yellow. Yes. Then, when the pH will reach 6.5 and go beyond 6.5, it will turn into blue. So, it will also be, yellow. Then, we have for the third one, what would be its color when the pH would be 5?
For phenolphthalein.
Yes,
Colorless.
it's colorless. Very good. So, what would be the overall color? You have to
Mm,
combine all these three colors. It would give you yellow, it would also give you yellow, it would give you colorless. So when you add yellow plus no color, we will get yellow. That's obvious. So
okay.
the correct option is yellow. Clear?
Okay.
Okay. Then we are given the table gives information about the three indicators. Okay, then we are given thymol blue. Color at pH 1 is red. pH at which the color changes is 3, and the color at pH 12 it's yellow. Congo red and phenolphthalein again. And which colors would be obtained when each indicator was added separately to pure water? Yes. What would be the color of thymol blue when it is added to pure water? What's the pH of pure water?
7.
7. Very good. It says that the pH, the color it gives you at pH 1, it's red, and the pH at which the color change takes place is 3. After that, the color at pH 12 becomes it's yellow. So what would be the color of thymol blue when it is added to pure water?
Um, Pure water. Yellow.
Yes, very good. Since we know that pH 7 is greater than 3 and its color change takes place at 3 and 7 is greater than 3, so it will be the color shown at pH 12, so it would be yellow. Now, what would be the color of Congo red?
Red.
Red, very good. What would be the color of phenolphthalein?
Colorless.
Very good. So, which is the correct option?
Mhm. D.
Yes, very good. It's T. Okay, then we are given for which reaction is a gas produced, adding calcium to water, adding dilute hydrochloric acid to silver, adding dilute sulfuric acid to copper, and electrolyzing the aqueous copper sulfate using copper electrodes. From which of these reactions is a gas produced?
Adding calcium to water,
What do we get?
get hydrogen.
Yes, very good. We will get hydrogen. Adding calcium to water, we know calcium is a metal when we react it with water. What do we get? We will get calcium
Hydrogen,
hydroxide and
calcium hydroxide and
hydrogen
more
gas will be
hydrogen.
produced. Very good. What about the second one? Adding dilute hydrochloric acid to silver.
It's below the like below
Yes, it's
the
below hydrogen in the
reactivity
reactivity
series.
series. Very good. So it won't react. What about the next one? Adding
Also
dilute
below
sulfuric acid. Very good. What about the last one?
the electron complete. It's like there's no gas involved because like the it's like copper dissolving an anode and like there'll be no gas involved.
Yes, very good. There is no gas being involved in this reaction, so only option A is correct. Then we are given the following equations represent the reactions of dilute sulfuric acid. Which reaction is not typical of a dilute acid? What do we mean by the typical reaction? Typical reactions of acids, they involve their, you can say, characteristic
Like
properties.
like hydrogen ions reacting the base.
Sorry?
Like hydrogen ions reacting the base. Typical acid reaction.
Yeah, reacting with bases. The typical reactions involves reacting with bases like the neutralization reactions, reaction with the metal carbonates producing carbon dioxide, or reaction with the reactive metals that will give you hydrogen gas. So in the first reaction, if you look at the first reaction,
Acid and
what is this
alkali
potassium hydroxide?
are basically
This is an this is a typical acid alkali neutralization reaction. Typical means the reaction will be can be a neutralization reaction, or
acid to
it it can be a reaction with the carbonates, which gives us carbon dioxide, or the reaction with metals, producing the hydrogen gas. The first one is a typical acid base neutralization reaction. What about the second one? It's copper oxide and dilute sulfuric acid. Copper
like
oxide.
copper
What's the nature of
oxide.
copper oxide?
It's like the metal oxide.
Yes, it's a metal oxide. Is it acidic in nature or basic?
Basic.
Yes. So this is again a typical acid base reaction. What about the next one? This is
B, uh,
what are we reacting in the option C?
reacting H2SO4.
H2SO4 is
Okay.
H2SO4 is the dilute sulfuric acid. What about the other reactant that we have?
Mm, Lead,
It's lead nitrate,
lead metal.
and we reacted with dilute sulfuric acid, and what we are getting? We are getting an insoluble salt, which is lead sulfate. PbSO4,
Oh,
it's
okay.
lead sulfate, and
Okay.
this is a insoluble salt which we called
Insoluble.
as a precipitation reaction, because you can see that this is S. It means that is this is an insoluble salt. So it is a Precipitation reaction. So we can say that this is the property of a sulfate ion rather than a characteristic reaction of acids. Clear? This is not a
Yes, it's clear.
typical reaction of a dilute sulfuric acid. And then in the last one, in option D,
Mm-hmm.
we have zinc carbonate and we reacted with dilute sulfuric acid. Is not this a carbonate? This is zinc
It's
carbonate.
carbonate. Yes,
Yes, so I told you that
carbonate.
neutralization reactions, reactions with the carbonates, and reactions with the metals, they are the typical reactions for acids. These are the three types of typical reactions for acids. So this is also one of the typical reactions. This is a reaction with the carbonate. So option C is the only correct option, which is not a typical reaction. Clear?
Yes, it's clear.
Okay, then we are given that a black powder, it is burned in air. The gas produced dissolves in water to form the solution R. The pH of R, it is close to 7. The gas, it is readily absorbed in aqueous sodium hydroxide. What type of substance is present in solution R? Strong acid, strong base, weak acid, or weak base?
Uh, is the black powder like carbon? So
Very
carbon
good.
dioxide.
Very good. It can be carbon.
uh,
When carbon burns, which gas do we get?
Carbon dioxide.
Very good. It will produce uh, carbon dioxide. Then, what will happen when carbon dioxide reacts with water?
It
When
will
that
form a
gas,
carbonic acid.
very good, it will form carbonic acid. If we have carbon dioxide and we react it with water, it will produce carbonic acid. What's the nature of the solution of this carbonic acid? What's the nature of it? Is it a weak acid or a strong acid or H2CO3? What's the nature of this solution, the carbonic acid that we will
Carbonic
get?
acid, it's like weak acid.
Very good. Carbonic acid, it's a weak acid, and we know weak acids are those acids that partially ionizes in water. That's why we say that its pH is close to 7. It's typically around 5.5.
Okay.
And then we are given this information that the gas is readily absorbed in aqueous sodium hydroxide. So, when a gas it is readily absorbed by sodium hydroxide, it confirms that it is an acidic oxide
Okay.
as it reacts to form a
Okay.
salt and water, right? What do we mean by acidic oxides? The oxides of non-metals.
Acetic acid.
Yeah,
Mm,
right?
so
So when it is written that the gas it is readily absorbed by aqueous sodium hydroxide, this is a confirmation that the oxide, that the gas it is an acidic oxide. So which is what type of substance is present in solution R?
weak acid.
Yes, it's weak acid. Option C, very good. Then we are given that which reaction will not occur using the cold dilute sulfuric acid? Will not occur. Formation of copper sulfate from copper oxide, formation of copper sulfate from copper, formation of hydrogen from magnesium metal, and the formation of carbon dioxide from sodium carbonate.
B, formation of copper to sulfate from copper.
Formation of copper sulfate from copper. Very good. What's the reason?
Because mm, because this it like involves the reactivity series of copper is below like the hydrogen in the series, and
Very
like
good. Yes. So to actually see that which reaction will not occur, we must need to look at the reactivity of the substances with cold dilute sulfuric acid. We need to just check that which of these reactants are able to react with the dilute sulfuric acid and which are not. So we know that copper, it cannot react with the dilute sulfuric acid because it is present below the hydrogen in the reactivity series. So it won't take place. So B is the correct option. Then we are given that the pH of an aqueous solution of hydrochloric acid is 2. What will be the pH of the acid after the addition of 10 gram of sodium chloride? What would be its pH? What will be the pH of the acid after the addition of 10 grams of sodium chloride? What's the nature of sodium chloride?
nature of sodium chloride is neutral, like seven
Yes,
around.
yes, it's neutral. Very good. We know that HCl, it is a very strong acid. What do we mean by strong acid? It means that it will completely dissociate into hydrogen ions and chloride ions. Right? This HCl, it will get dissociated into hydrogen ions and chloride ions. And how do we determine the pH of an acid? On which basis? We determine the
How do we
pH
get
by the concentration of these H plus ions that are
concentration?
given by any acid. As far as the nature of the sodium chloride is concerned, we know that it is a neutral salt that is formed from a strong acid, which is HCl, and a strong base, which is sodium hydroxide. And when we dissolve this NaCl into water, it breaks into which two ions? It breaks into sodium ions and chloride ions.
Chloride.
Now, we know that neither this sodium ions nor the chloride ions, they react with water to, like when we dissolve it into water, none of these two ions, they will react with water to give us the extra H plus ions or OH negative ions. And we know that we determine the pH of a solution only by the concentration of H plus ions. So even though if I add it, even though if I add sodium chloride, its ions are not able to give us any extra H plus ions. Therefore, it cannot affect the concentration of the hydrogen ions. They remain unchanged. Therefore, the pH also remains unchanged. There won't be any effect. We know that pH is simply the measure of concentration of H plus ions. Measure of concentration of H plus ions. So adding sodium chloride won't give you any extra H plus ions. So the pH won't get affected. It will remain 2. Clear?
Yes, yes, okay.
Okay, then we are given aluminium sulfate. It is used in water treatment. Aluminium sulfate is acidic. The table shows the result of the tests on 4 different samples of treated water to which sample had an excess of aluminum sulfate being added. Sample A, pH of sample is 3, reaction with an excess of aqueous ammonia white precipitate. When the pH of sample B, whereas the pH of sample B it's 3, and the reaction with an aqueous excess of aqueous ammonia, there is no reaction. For sample C, the pH is 7, there is no reaction. For sample D, the pH of the sample is 11, and the reaction gives you white precipitate.
Mm, really,
We are given that the aqueous aluminum
yes,
sulfate it is acidic. What do we mean by that? It means that a sample that will be containing an excess
excess.
of it
Okay.
must have a pH value very lower than 7,
Yeah.
right? It must
Yeah.
be very lower than 7. That's when we can consider that it has the excess of aluminum sulfate. It's written excess of aluminum sulfate, and it's given that its nature is acidic. So option C and D cannot be the options, right?
Okay. Yeah.
Because their pH is 7 and above 7. So we can have only option A and B. Now, which one seems correct?
The
The reaction with an
A
excess of aqueous
is
ammonia.
A
White precipitate?
precipitate. Yes.
Why?
Because it reacts with the ammonia reacts with the aluminum to form aluminum hydroxide.
Yes, very good. Excellent. So, option it will give you aluminum hydroxide, which is a white precipitate. Option A is the correct option. Clear?
Yes. Okay.
Okay. Then just look at the second part. This is about the oxides. We are given that both calcium oxide and calcium hydroxide they are used to remove sulfur dioxide from flue gases in industrial plants. Which row classifies the calcium oxide, calcium hydroxide, and sulfur dioxide? You have to tell the nature of these things. Calcium oxide, is it acidic or basic? Basic calcium hydroxide, and then sulfur dioxide.
Yeah. Okay. Then calcium oxide. Yes.
This is a metal oxide, right?
Yes.
Calcium oxide, it's
Metal
a
oxide.
metal oxide, and
Yes.
metal oxides, they are basic.
Basic. And calcium hydroxide is also metal. It's a basic. So D.
Uh, this is basic, and sulfur dioxide is acidic. Option D. Very good. Option D is the correct option. Then we are given that which row identifies an acidic, which row identifies an acidic oxide and a basic oxide?
Um, um, C. Carbon dioxide is acidic oxide.
Very
And
good.
copper.
Calcium oxide is a
Okay.
basic oxide because it is a metal oxide. So carbon dioxide will be the acidic oxide. What about the basic oxide?
Copper. It could be basic oxide will be copper oxide.
Option C, right?
Yes.
Very good. Okay, then we are given the oxides of the two elements X and Y. They are separately dissolved in water, and the pH of the each solution it is tested. Oxide tested, oxide X, it gives you the pH of 1, and oxide Y gives us the pH 13. Which information about X and Y is correct? Oxide is acidic, which oxide is basic, which contains metal and which contains non-metal.
Um, acidic.
Oxide X, it has a pH of 1, which is a
Acidic.
strong acidic. Very good. The oxide of X
Y is
must be
basic.
acidic, right?
Yes. So
Oxide is acidic is X, and X should be a metal or a non-metal. Acidic
Acidic
oxides, are
oxides,
they made from metals or non-metals?
non-metals,
Yes, if X is acidic, it should be a non-metal. X
non-metal.
must be a non-metal. So
Okay.
A cannot be the correct option. If X is acidic, X must be a non-metal because its pH is indicates that it is strongly acidic. If you look at the pH of oxide Y, its pH is 13, which means that it is strongly basic. Oxide is basic, and we know that basic oxides, they are made from metals or non-metals.
They're made from metals.
Yes. So Y must be a metal. Option B is the correct option.
Okay. Okay.
Yes, it's X by Y and then X. Yes. Got it?
Yes, I got it.
Okay. Then we are given that the reaction of the three metals and their oxides are shown. Metal 1, add uh, dilute hydrochloric acid to metal. It gives us the reaction, like the reaction takes place, heat metal oxide with carbon also takes place, it reacts and it does not react. It reacts metal 2, it reacts with the dilute hydrochloric acid to metal, and it does not give this reaction. Metal 3 does not give this reaction but gives the second reaction. What is the order of reactivity of these metals from most reactive to least reactive?
That's what I have to do.
If a metal reacts with acids, do we consider that metal as more reactive or less reactive?
Reactive. Most reactive.
Yes, the metals that react with dilute hydrochloric acid, they are generally more reactive than those that do not. It means that metal 1 and metal 2
Two
must be
and
more
most.
reactive than
Yes.
metal 3, right?
Yes.
What other information can we get
That
from the reaction with carbon?
reaction of carbon. This is like
Yes,
heat metal oxide with carbon. This is like for oxygen. Like
oxygen.
we can.
No, we can use this reaction. We should know that carbon, it can only take away the oxygen from metals that are less reactive than itself, that are less reactive than carbon. If a metal
Carbon.
oxide does not react with carbon, what do we mean by that? It indicates that the metal is very reactive. It is stronger than carbon. Carbon does not have the tendency to take away the oxygen from that metal. So, if you look at metal 2's oxide, does it react with the carbon? It does not. It means that metal 2 is the most reactive of the three because it is the carbon, it is not capable of taking away the oxygen from that metal, from the oxide of that metal. Metal 1's oxide, it reacts with carbon, meaning it is less reactive than metal 2. But still, it is more reactive than metal 3 since it reacts with acid. We just saw it from the first reaction, we saw that these two are more reactive than the third one. From this second reaction, we saw that this is the most reactive among all. If a metal oxide does not react with carbon, it means that that metal is very reactive. It because it is stronger than carbon. Clear or not?
Yes, it's clear.
So what should be the order? The order from most
One,
reactive to
two,
least
three.
reactive.
One, two, three.
No, we know that
Like two,
3
one.
is least
C.
reactive. But from 1 to 2, among 1 and 2, 2 is
Two.
more
More
reactive because
reactive.
its oxide does not react with carbon. Carbon does not have the tendency to take away the oxygen from it.
Okay. Okay. So
So
it's
it would be 2,
two
1,
and
and
three.
3. Option C. Part of the periodic table is shown which element form the basic oxides. Where do we get the basic oxides? This is group 1 and group 2. Are these metals or non-metals? Group 1 and 2.
1 and 2 are like metals. Like,
Yes. And these are the non-metals.
mm,
What do we which type of oxides do we get from metals? Acidic or
like
basic?
basic oxides,
Yes, very good. So which elements form the basic oxides?
1 and 2.
Yes. Because these are the metals, they will give you the basic oxides, and 3 and 4 they are non-metals, so they will give you the acidic oxides.
Okay.
Then we are given which element forms an acidic oxide? Calcium, lithium, magnesium, or sulfur? Acidic oxide. We know that metals give us basic oxides. Which of these are metals?
The metals
Calcium,
are calcium and magnesium.
lithium is also a metal.
Okay.
The elements that are present in group 1 and 2, they are all,
Basic.
yes, they are all metals and they give us basic oxides. Calcium, lithium, and magnesium, they are, what's the lithium, what is the atomic number for lithium? It's 3.
Mm.
So this is also a metal. These three elements, they belong to group 1 and 2. They are all three metals, so they will give us the basic oxides. Only sulfur is the non-metal and it will give you an acidic oxide. So the correct option is option D.
Okay.
Part of the periodic table is shown F and G. Which type of chemical bonding is present in the oxide of F and in the oxide of G? F, it is again a metal, and G is again a non-metal. Which type of bonding will be present in the oxide of a metal and in the oxide of a non-metal?
F is F is ionic because
Mm,
like
ionic.
metal. Yes. F
F is a metal or a non-metal?
metal.
F is a metal, very good. And what would be the type of the oxide of this F?
They like basic metal. Basic oxide.
Yes, they will give you basic oxides. So, which type of bonding will exist?
Ionic.
Ionic bonding, very good.
Um,
Because F, it is a metal, and in the oxide, we have the other element that we have is the oxygen, which is a non-metal. So there will be a transfer of electrons from the metals to the non-metals, giving us the ionic bonds. F will have the ionic bonding, and in oxide of G, we know that G, it is a non-metal and it will react with oxygen, which is also a non-metal. So two non-metals, they are only combined with covalent bonds. So which is the correct option?
ionic and covalent. C. C correct.
Ionic and covalent?
Yes.
Yes, very good. Then we are given that which oxide is classified as an amphoteric oxide.
Aluminum oxide.
Very good. Zinc oxide is an amphoteric oxide. Which type of substances will react with zinc oxide? Acids and bases. Bases only, neither acids nor bases.
Acids and bases.
Yes, option A, very good. The oxides of two elements, X and Y, they are separately dissolved. I guess we have done this before. Option B was the correct option. It is
Yeah.
repeated. Okay, carbon forms two oxides, carbon monoxide and carbon dioxide. Which row describes these two oxides? Carbon monoxide and carbon dioxide.
Mhm. Mo- carbon dioxide is
Carbon forms two oxides. Which row describes the nature of carbon monoxide and carbon dioxide?
acidic. CO2 is acidic.
Sorry?
Mm,
Carbon monoxide?
Carbon dioxide is acidic,
Very good.
and carbon
Carbon
monoxide
dioxide?
is also acidic.
No, carbon monoxide, it is a neutral oxide. It does not
Okay.
react with the acids or bases to form salts. So it does not, um, it cannot be classified as acidic or
Okay.
basic. This is a neutral oxide. And carbon dioxide, it is an acidic oxide. So which is the correct option?
We can use D. No, C.
Yes, it's C. Very good. Okay, then we have only this last one, which is about the preparation of salts. We are given copper sulfate crystals are blue. They are made by adding an excess of copper oxide to sulfuric acid. The mixture is heated and stirred. The nature is then filtered and the filtrate is allowed to evaporate, leaving blue crystals. Why is filtration necessary? To remove the soluble impurities, to remove sulfuric acid, to remove the blue crystals, or to remove the unreacted copper oxide?
Yeah. Why is filtration is necessary to
Yes,
remove unreacted
copper oxide.
copper oxide.
Yes, very good. It's option D. Okay, which barium salts are soluble in water? Barium carbonate, barium chloride, barium nitrate, or barium sulfate?
Sodium salts are soluble in water.
Yes.
Uh, sodium salts are soluble in water. Mm, Barium chloride and barium nitrate.
Which of these
Hmm?
are soluble? Barium carbonate? Which one?
No, chloride. C.
Barium chloride and barium nitrate. Right?
Yes.
Very good. We know that most of the chlorides they are soluble, except when we learned the solubility rules, we saw that most of the chlorides are soluble except silver, lead, and mercury. And when we talk about the nitrates, all the nitrates are soluble. And when we talk about the carbonates, most of the carbonates they are insoluble and except those that belong to group 1
Okay.
elements and ammonium. These are the solubility rules that you need to remember.
Okay.
And barium sulfate, it's also insoluble, but most of the
Okay.
sulfates they are soluble except barium, calcium, and lead sulfate. These are the exceptions. Other than these, all the other sulfates are soluble. So you need to memorize the rules, the solubility rules.
Okay.
So option C is the correct option. Clear?
Yes, it's clear.
Okay. Um, we will do it in our next class. This is the last PDF and it's almost done. After this, we will continue with the subjective part. And there is one more thing I want to ask that do you have school tomorrow?
No.
Okay. So when can we take the class tomorrow?